Next topic is finite automata with output. So in the previous videos I discussed about finite automata without output, that is DFA, NFA and epsilon NFA. Okay, so in this video I am going to explain you about the finite automata which belongs to the category with output. Okay, so there are two types of machines. One is Mealy machine, another one is Mealy machine. So today I am going to explain you what is the difference between Mealy machine and Mealy machine. In Mealy machine, the output we can see along with the state. Okay, so I'm just drawing the diagram for that. Suppose there are two states Q0 and Q1. Okay, and I'm showing some transitions over the input symbol A, B. Just I am showing one example only here. So in case of Mealy machine, we are showing the output along with the state, that is output on state. Whenever we are reaching the state Q0, it will produce as output 1. Whenever we are reaching the state Q1, it will produce as output 0. Okay, so in case of Mealy machine, we can see the output along with the state. So it is a machine with a finite number of states and for which the output symbol, this is the output symbol, 1 and 0 are the output symbol, depends only upon the present state. So when we are in state Q0, it will produce as output 1, and whenever we are in state Q1, it will produce as the output 0. So the output symbol depends only upon the present state of the machine. But in case of Mealy machine, here the output is on transition. So this is a deterministic automata. In case of Mealy machine, the output is on transition. Okay, so whenever we are in state Q0, on seeing the input symbol A, it will produce some output, say 1. Okay, from Q0, whenever we are seeing the input symbol B, it will produce as output 0 and reaching the state Q1. Q1, while seeing the input symbol B, it will produce as output 0. Okay, so just I am giving one example to you in order to differentiate between Mealy machine and Mealy machine. So in case of Mealy machine, the output is on state, and in case of Mealy machine, the output is on transition. So in the case of Mealy machine is a machine with finite number of states and for which the output symbol, here the output symbols are 1 and 0. Output symbol is a function of present input symbol as well as the present state. So the output symbol depends upon the present state and present input symbol. Both machines are represented by using 5 tuples Q, sigma, delta, del, Q0, lambda, Q0 or Q0. Okay, so from DFA and NFA you already know about what is Q, what is sigma and so on. So what is Q? Q is a finite set of states, sigma is a set of input symbols, and the new tuple which is output alphabet. Okay, so delta is the output alphabet and del is a transition function, Q0 is the starting state or initial state, and lambda here it is the output function. So these are the extra 2 tuple. You can see there is no final state here because every state is producing some output. So no need to mention the final state. So these two machines are represented by using 6 tuples Q, sigma, delta, del, Q0 and lambda. Q is a set of finite number of states. Sigma is a set of input symbols. This is delta is the output alphabet. Del is a transition function. Q0 is the starting state or initial state, and lambda is the output function. So while taking Mealy machine and Mealy machine, only the lambda will change. That is, here I already told you in Mealy machine, the output symbol depends upon the current state and the current input symbol. So here the output function lambda is equal to, it depends on the current state and the current input symbol. Okay, so the output alphabet depends on the current state and the current input symbol. That is Q cross sigma gives delta. But in case the output alphabet depends on the current state only. So how we can write lambda q? Output depends on the state only. Okay, so and what about the transition function? I already told you these two machines are deterministic machine. We can't say it is DFA, but both are deterministic machine. If we are taking a state, you need to show the transition on both input symbols. Okay, it will goes to only one state. So delta here is that the transition function for both Mealy machine and Muri machine is Q cross sigma gives Q. Same transition function as that of DFA. Now just I am saying one example, that is suppose this is our automata for Muri machine. Okay, and our input is AB. Suppose our input is AB. So how this machine will produces the output while seeing the input AB? What will be the output while seeing the input AB for this particular machine? Okay, so initially we are in state Q0. What is the input symbol? A. Q0, while seeing the input symbol A, it is moving to state Q0. While seeing the input symbol A, it is moving to the state Q0. The next input symbol is B. Q0, while seeing the input symbol B, Q0, while seeing the input symbol B, it is moving to the state Q1. Okay, so our input our string is AB. So while we are in initial state Q0, while seeing the input symbol A, it is moving to state Q0, and while seeing input B, it is moving to state Q1, that I mentioned here. So what will be the output? From Q0, we will get the output 1. Q0, we will get the output 1. Each state will produce some output. Then what about Q1? It will produce output 0. Okay, so whenever we are having the string AB, the given Muri machine will produce as output 110. So here we can see the length of the string here is, the length of the input string here is 2, and the length of the output string produced here is length 3. So if we are having an n bit length input string, it will produce as n plus 1 bit output. Here 2 less, the length of the input string is 2, and we produced a string which is of length 3. Okay, so 2, the output is 3. Okay, so in case of Muri machine, a string of length n as input, then output produced will be a string of length n plus 1. Why it produces n plus 1 length output string? Because even without seeing anything, in Q0, it will produce some output. Without seeing any input symbol, Q0 will produce some output. Okay, so that's why a string of length n as input, then the output produced will be a string of length n plus 1 in case of Muri machine. Then what about Mealy machine? So this is our Mealy machine, and suppose our string is AB. Okay, suppose our string is AB. So in case, for initially we are in state Q0 while seeing the input symbol A, Q0 while seeing the input symbol A, it is moving to state Q0, and while seeing the input symbol B, it is moving to state Q1. Okay, so I already told you in case of Mealy machine, the output is on transition. So Q0, while seeing the input symbol A, Q0, while seeing the input symbol A, it produces output 1. Q0, while seeing the input symbol B, it produces output 0. So the input string is of length 2 here, then output string is of length 2 here. So in case of Mealy machine, if the input is of length n, it will produce an n bit length output string. So n bit input, it produces n bit output. But in case of Muri machine, it will produce n plus 1 bit output string. Because without seeing any input symbol, the starting state will produce some output. So that is the main difference between Muri machine and Mealy machine. So difference between Muri machine and Mealy machine. Muri machine and Mealy machine are the machines which belongs to which category? Finite automata with output. And both are represented by using 6 tuples: Q sigma, delta, del, Q0, lambda. Where Q is a set of finite state, sigma is a set of input symbols, delta is the output alphabet, del is the transition function, Q0 is the starting state, and lambda is the output function. Then output function, I already told you Muri machine output is on state. So each state will produce some output. But in case of Mealy machine, the output depends on the current state and the current input symbol. So current state and current input symbol, it will produce some output. And both machines are deterministic. So the transition function is Q cross sigma gives Q. And in case of Mealy machine, if the input is of n bit length, then it will produce n plus 1 bit output, because without seeing any input, the starting state will produce some output. So it will produce n plus 1 bit output stream. And in case of Mealy machine, if the input is of length n bit, it will produce an output of length n bits. The main thing you need to see here is, in case of Mealy machine, the output is along with the state. In case of Mealy machine, the output is along with the transition. Okay, so in the next video, I will explain you how to design a Mealy machine.